For instance, if I see I've got two 45s and a 90, and I have two sides, a lot of you are like, well, why am I not just doing the Pythagorean Theorem? Because that's what I'd always do anyway. And you could. But if I know my form for this, both of my legs have a value of x. The hypotenuse is just that value times the square root of 2. So if I know the form, I can just do this. I'm done. Okay, that's kind of simple. Well, could I get it without knowing that? Sure. We still know using the Pythagorean Theorem, I could do 2 squared plus 2 squared equals this x value over here, squared. But here's why I'm talking about more of our relationship with keeping a radical. Okay, 2 squared is 4. So 4 plus 4 would be 8. And here's where life is going to change, where we're going to go back to something that we've covered already. When I get here, and I get, okay, so x is going to be the square root of 8. If I can break down the radical to its simplest form, I should. If you had a question like this on a standardized test, it's not going to have the answer as the square root of 8 because that's not its simplest form. Remember, whenever I can take a radical and I can break it down, one of my values being a perfect square, one of them not being, I can take this a little bit further. Hence the need to know your squares, at least up to 12. Because when I find that perfect square, square root of 4 is 2, it gets out of radical jail with its new identity. The square root of 2, though, isn't perfect. It has to stay. Now, if you want to go through all of this on all of these questions, you can go ahead and keep using the Pythagorean Theorem sometimes. But other times, if you just know, oh, it's whatever that side is times the square root of 2, that'll get me to the answer. It works a lot easier for you. But like I said, you may get into situations sometimes where you can't even do that. Ooh, like 3. You're like, all you gave me is one side. All you gave me is the hypotenuse. How am I supposed to do this? We're going to make a little algebra equation out of this, but I have to know the form to even be able to do it. So I look at this and I say, okay, if I have the hypotenuse, that's this side. So x times the square root of 2 equals this because, well, that's my hypotenuse and that's the value I get. You're like, ooh, but this is kind of cool. If I told you to get x by itself and you're multiplying it by the square root of 2, what would you do to both sides? Divide, okay. Well, if I divide by the square root of 2, the x value equals 11, which just means each of my legs has a length of 11. Now, if I knew my form, did I actually have to do that algebra? Not really. Because if I know that x times the square root of 2 is this, and the legs are just x, basically I just look at the number in front of that and I say, oh, it's that number. Okay, I'm done. But you have to, again, you have to have a feel for the formula to be able to do it. Now 5 takes that, but it takes it one step further. You're like, okay, oh, yeah. Actually, 5 is going to run the exact same way.
Oh, okay.
So, yep, we're going to hit that little dilemma we could run into right now. What happens when there's not a radical there? You're like, well, wait a minute. Number 5, so x square root of 2 equals 14. That's kind of weird. So if I divide that by the square root of 2, okay, so I get x is 14 over the square root of 2. But that kind of looks weird because that doesn't look like x square root of 2. It's going to in a minute. Because we have to do what's called rationalizing the denominator. And we've done this before. To rationalize the denominator, in other words, I can't have a radical in the denominator. I'm not supposed to. I let that slide on day 1, but on these, I'm not going to have us doing that. Whatever radical's in the denominator, we're going to multiply the numerator and the denominator by that radical. So we're going to do the square root of 2 to both. By doing that, I'm not changing the value because I'm doing the same thing to both places. So I work this out and I go, okay, so I've got 14 times the square root of 2 up top, because again, the 14 is not under a radical. I cannot multiply those together. But the bottom, they are both under the radical. So square root of 2 times square root of 2 would be the square root of 4, which is just 2. That's the whole idea of doing this rationalizing, so I don't have a radical in the denominator anymore. And if at this point, the only thing I might be able to do still is look at the values that now are no longer under the radical. If they simplify, I need to do that. 14 divided by 2 is 7. And I've found what my other two legs are going to be. Because, and here's the way you can even check it. Now I know most of you don't like checking things. But if I ever get an answer, I'm like, well, that kind of looks different. I'm not sure if that's right. I'm just going to do the Pythagorean Theorem to it for a second. So if I know each of my legs are 7 times the square root of 2, and I know the hypotenuse is 14, this isn't really going to take me this long to figure this out. Because I go, okay, 7 squared is 49. But the square root of 2 squared just means the squared and the square root cancel. Okay? So I literally square the 7, but when I get to the radical, this just cancels it. So it'll be the same thing on the second one. Again, the 7 doesn't have the radical, that's why it gets bigger. And then 14 squared is 196. So is 98 plus 98 equal 196? If it does, I've done the work right. If it doesn't, I probably did some little small error somewhere. But that's how we're going to have to deal with some of these things. We're going to have to feel comfortable and work with radicals to make this work out for me. So that's kind of a little bit of background on how some of these are going to work. Now, some of you may even start to see a pattern develop with this to make it go faster. I'm not going to say it till after we've done number 7, but I'm hoping after we do number 7 you might see something. It might save you some time and effort. But if not, what we just did will always work. Same thing here. Look at what side you have, the hypotenuse. That's x square root of 2. So I'm like, okay, x square root of 2 equals 10. And I know from the one that I just did, I'm going to be dividing by the square root of 2. So I'm like, okay, so 10 divided by the square root of 2. Can't have the square root in the denominator. And even if you think you become an expert after like 3 questions, I'd still jot some of this stuff down, even if it's on a side piece of paper or something. Because once you get the hang of this, you're just going to start flying through these. Here's where I'm hoping you start to see the pattern. You look at 5, you're like, the hypotenuse is 14, the leg is 7, square root of 2. Number in front's half. Number 7, the hypotenuse is 10. The leg is 5, square root of 2. There's a relationship building here. You're like, wait a minute, so if that happens, I can just take half of that and put a square root of 2 on it and it works every time? Yes, because you've noticed the pattern involved. Just like when you're doing it the other way, if I have a leg, I know the hypotenuse is just add a square root of 2 to it. It's trying to find those patterns, work it out, and that really gets you more well prepared for standardized testing. But let's see if we can apply this without doing all the math. My legs are each 4 on number 9. What's my hypotenuse going to be? 4 square root of 2. Because the pattern is whatever this is, if I times it by the square root of 2, I get the hypotenuse. Could I do the Pythagorean Theorem? Sure. I'm not going to tell you you're wrong if you do. It's just going to take you some extra time. That's all. 16. Work it backwards. Think about the pattern. What are each of my legs going to be? I heard somebody kind of whispering in the back. 8 square root of 2. Because it's always going to be half of my hypotenuse value with the square root of 2. You know now how to get there. If you happen to forget, you always can work it backwards and get there. We did it mathematically so you could see it. But again, it pays to know the forms on this. If you actually take real legit trig next year, those are the types of things you're going to be expected to know off the top of your head without like a cheat sheet or anything else like that. So that's why we introduce it this year, just so you can kind of start to get a feel on how those work. So as you're doing them through any of these, I can find that same pattern. Find the value of x in each triangle. Okay, if it's 45, 45, 90, I know my legs are going to be the same. And I also know that my leg times the square root of 2 is going to give me my hypotenuse. Keep it simple. What if they do something weird? Okay, like what? Like 3. I just see right angles everywhere. Okay, but when you have a square and you cut a right angle in half, what's half of a right angle equal? 45. So even though it doesn't look just like number 1, it actually works just like number 1 did. I have a leg, which means I also know how long this is. And if instead of looking at it as a square, I'm looking at it as a right triangle, I'm looking for the hypotenuse, which is just my leg times the square root of 2. Again, I could do the Pythagorean theorem, that's fine, but I'm going to end up back at this one way or the other. It just saves me some time and some effort. So let's see. What part do I know on number 5? What's that 8 represent? Excuse me, right, the hypotenuse. So I think back and I'm like, okay, so these are both x. That's the hypotenuse. What's one of the legs going to be? 4 square root of 2. Because again, when I have the hypotenuse, we think back to like we did on number 11. Half of this, pop the square root of 2 on it. And again, if you're not sure, I know this is going to be the same thing, do the Pythagorean theorem and see if it works. And then when you start getting that reinforced, you're like, ooh, this is easy. I like this stuff. I just get to kind of manipulate things. I don't have to show a lot of work. Exactly.
Yeah, we don't really have to show our work.
No, on these you don't. And it's going to be one of those I'm probably not going to end up finding out until the quiz if some of you know this or if you're just jotting down answers from somebody. This is the one part of this that scares me. But I guess, yeah, I was going to say, I'm hoping you're finding this to be kind of easy. Now the other side is doing the same thing. I'm going to redraw my triangle here because I got my 30, 60, 90 on the other side, and that really doesn't help me when I'm here. And if you're having issues with mine, just flip yours back over for a second because the same one's up at the top on the other side. Now this one, all 3 of my legs have a little bit different of a look. And here's how I know how to keep these straight. Because I'll have people come up to me and they'll say, how do I remember which one's x, which one's 2x, which one is x squared root of 3? Here's how this works. Your smallest angle, 30, will always be opposite from your shortest side, x. Because if I plugged a number in for each of these, x is going to be the smallest number. My biggest side, 2x, is always going to be opposite from the biggest angle, my right angle. And then the one in the middle, the 60, x squared root of 3 is going to be bigger than x. but it's going to be smaller than this. And that's how I keep track of it. So if I'm ever not sure, I just kind of look at the angles. So I look at these and I go, okay, number one, I always like to put all my angles in here just so I can think a little bit about how this works. So I look at this number one and I go, okay, what do I have? I have this side, which is opposite from my 30. So I start thinking about it, I'm like, okay, 30 is x. So this is, and this is going to get confusing for a second because you're like, well, x is right there. This is my x. The 60 side right here is x square root of 3. Whatever this is, times the square root of 3. And then my hypotenuse is 2 times whatever my short side is. So 2 times 8, or 16. And I like to look at it that way and kind of be thinking about this as I'm doing them to help me think that out a little bit. So I always, again, put all of my angles in if they don't give them to me. And then I usually will just mark that first angle that I'm looking at here. That's x. So I'm like, okay, so I've got x square root of 3, 2x. Now I'm ready to plug the numbers in. If this is x square root of 3, and this is 2x, 2 times 14. It's one of those patterns you just have to get used to. And if it takes writing the pattern on your triangle before you get the numbers in, not a bad idea. Now, are you always going to be given that one? No, of course not. Here, I'm working with the 60-degree angle first. I got to do a little work this time. Because I'm like, well, wait a minute. This side is x square root of 3. And this side is x, and this side is 2x. But this side, x square root of 3, wait a minute. I don't know what x is yet. That's what I have to figure out. So like we did before, to get x alone, I've got to divide by the square root of 3. Oh, crap, party, but then I got a radical in the denominator. That's true. So I have to fix that. I have to rationalize it. So, square root of 3 over square root of 3. And this will be the most work you ever have to do on any of these. So it's not like it's anything terrible. 6 square root of 3 over 3. Because again, 3 times 3 is 9. What's the square root of 9? It's 3. And then reduce what you can. 6 divided by 3 is 2. So 2 square root of 3 is my x. That's my short side. It's my side opposite my 30 degrees. And then 2x becomes 2 times this. So 2 times 2 square root of 3. Now that I really can't tell you a good shortcut for. If you get to a point where you're doing that all mental math, wowzers. But for now, I would just say, when you get into that situation where it's 60, you're going to want to do a little bit of math to figure out what that actually breaks down to. Because whatever this equals, once I break it down, is what's called my short side. My side that's opposite from 30. Like, ooh, it's kind of crazy. It can be. But again, it all comes back to, do you know this? And that's what the key is going to be on these. 7, ooh, which side do I have on 7? The hypotenuse. So I go back and I'm like, okay, I'm going to mark my sides here again. That's just x. This is x square root of 3. This is 2x. Okay, so if 2x equals 20, what's x equal? 10. So I know what my short side equals. Because this is always going to be half of my hypotenuse. It never changes. And if I know this is, my x is 10, this is x square root of 3. I just pop it in front of square root of 3. Yay, no math, except, well, dividing 20 by 2. But again, it comes back if I know my sides. Once I find x, everything else just falls into place. It's kind of nice. Ooh, what else we got here? Looks like we've got ourselves a hypotenuse again. You're like, wait a minute, it's like 2 triangles. Right, I'm going to mess with you sometimes. See how well you're paying attention. But this is my hypotenuse. So that's what 2x is going to equal. So when I solve this and find x, that's my short side, my side opposite of my 30. So this guy is 9. And then my long side, always just that value with a square root of 3 on it. So my y, or my height of my triangle, would be 9 square root of 3. Patterns, patterns, patterns. Oh, boo, I wanted a different one. I'm skipping 11. We've just done 2 with hypotenuse in a row. That's going to start driving me crazy. Let's go to 13. So 30 degrees. That's my short side. That's my x. Life is good. Because if that's my x, my long side just tacks the square root of 3 on it. And my hypotenuse is just 2x, 2 times that. Or 40. That's what we're shooting for on these. And instead of doing what I originally had planned to do, I am going to save the app packet for tomorrow. So, your job for now is to finish the evens on this sheet, okay, as part of the next homework check coming up on Friday. Let me see.